Alright, so this is our final video in the chapter, so great, we're almost done with chapter 1. In this video we're talking about a method called linear programming. Should be a review of what you did in previous classes, however, I'm going to go ahead and tell you it's not used at our level in high school a lot. Now in the real world, it is used a lot to actually track inventory and determine how much of a certain materials you might need and that type of thing. So don't just completely ignore it, actually pay attention to it and stuff, and just be aware, hey, it is used, okay? So it's pretty cool to find some math that actually has some real world applications. All right, so the process of optimization is a process where we find the maximum or the minimum or both of a particular function. So linear programming is the process of optimizing a linear function that's subject to a system of constraints. Okay? And these constraints are going to be represented by linear inequalities. The graph of these constraints is called the feasible region. Now, here's a couple of different feasible regions that I have here. Feasible region can either be bounded or unbounded. It's bounded if the figure, the shape that it makes when you're finished with the graph is closed in on all of its sides. For instance, this bounded region has 4 sides and it's closed in on all 4 sides. Or a feasible region could be unbounded, which means some of the sides are closed in, that's fine, but then you have this open area, which just kind of means graphically it kind of goes on forever in that direction. Most of the time, at least at our level, in high school level, we're going to be talking about unbounded regions, we're going to be talking about bounded regions, but just be aware that unbounded is totally possible. Okay? So, let's move forward and actually try an example. What we want to do is find the maximum value of our function c equals 3x plus 4y. Here, c could represent the cost to build a car, where x represents maybe amount of sheet metal that you need that Ford Motor Company needs to buy, and y is the number of electronic computers to monitor the engine that Ford Motor Company needs to buy. Subject to the following constraints. So we're told that x has to be bigger than 0, y has to be bigger than 0, and x plus y has to be less than or equal to 8. Our linear constraints, if we're talking about a real-world problem, could be something about maybe the number of people you have working in your factories, the number of factories you have, time, how much money, how much capital do you have, or how many resources do you have. There's all kinds of things that these constraints could represent. Okay, so just keep that in mind. Again, like I said at the beginning of this video, this stuff is used in the real world. We're just barely scratching the surface. So what I want to first do is I want to graph these constraints. Okay, so to do that, I need to draw a sketch of my coordinate plane. So again, it's just a sketch. As you've seen in my previous videos, I am not an artist. Okay, so again, I want to just go about 6 units out, or maybe let's try to go 8 units out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go 10 units out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can go as far out or as far in as you want. Again, it's just your own sketch. And now what we want to do is to graph each one of these inequalities. I'm going to do top one in red, middle one in green, and then the bottom one in blue. Okay, so we'll just take this one at a time. Again, if you have y by itself for these inequalities, you can use the calculator to assist you like we saw in the previous videos. If not, you're going to have to figure it out on your own, and that could be a little challenging. Okay, so take your time and use some common sense. My first inequality, the top one, my inequality symbol has a line under it, so I know my boundary line has to be solid for that, and it's at 0. Well, it's at x equals 0, so I'm looking for the line where x equals 0. So x equals 0 is pretty much my y-axis. That's my boundary line. Okay? Now, I want to go ahead and shade. I'm looking for all the values where x is bigger than or equal to 0. Well, I'm going to pick a test point. This time I can't use 0, 0, so I'm going to try this point right here. 1, 0. First number is your x, second number is your y. Again, this is just scratch work, so I'm looking at this point right here. If this point works, I'm going to shade to the right. If it doesn't work, that means everything to the left has to work. So let's shade, do some scratch work. So I have 1 is greater than or equal to 0, which is true. So I'm going to shade everything out to the right. Okay, and this point right here, I'm just going to emphasize it real quick because it's going to come in handy later. That's 0, 0. Okay? Now I'm ready to go on to my next inequality. Y equals 0. But before I do that, I'm going to get rid of my scratch work. I don't need that anymore. So the inequality y equals 0. I have y by itself, so you could use your calculator to assist you if you need to. Graph it and then go to your table to find some points. I don't really need to though. So I'm going to go pick a point. So y equals 0 is right here. And the line y equals 0 is essentially the x-axis. And notice that my boundary line, again, is solid because there's a line underneath that inequality symbol. I want to find all of the points to shade that are bigger than or equal to 0. So I'm going to pick a test point. I'm going to try this test point right here. 0, 1. So that's my x, that's my y. So again, it's just a test point. I'm doing some scratch work. So I have 1 greater than or equal to 0. Well, that's true, so I need to shade above the line. Okay, again, just a sketch. And then finally, my last inequality, actually get rid of scratch work first. My last inequality, I do not have y by itself. So before I do anything else, I'm going to do a little bit of scratch work to get y by itself. So to get y by itself, I need to move x over to the right hand side, so minus x on both sides. So y less than or equal to negative 8 minus x. 8 minus x. Okay, so now y is by itself, so now I can use my calculator to assist me, which I am going to do. Okay, so just like we did in the previous video, we want to graph that, 8 minus x. We want to graph to see what our boundary line looks like. It's going to look something like this. Okay, and I have a line underneath my inequality symbol, so my boundary line is going to be solid. So let's go to the table now and get some points. Again, since it's a straight line, I need at least 2 points. Obviously, the more points you have, the better. I'm going to try to find the point where it touches the y-axis and the point where it touches the x-axis, because that's going to help me down the line. And the reason why I want to find the x-axis, because that's where this boundary line is, the red boundary line is on the y-axis, and I want to find where it touches the x-axis because that's where the green boundary line is. And I want to know where those boundary lines intersect. Okay? So, what I want to find is, for the y-axis, I know my x has to be 0. So my point when x is 0 is 8. 1, 2, 3, 4, 5, 6, 7, 8. So this point right here, that's 0, 8. All right, and I want to find where it touches the x-axis. So when y is 0, it's when it's going to touch the x-axis. So at 8, 0, 1, 2, 3, 4, 5, 6, 7, 8 is where it touches the x-axis. That's at 8, 0. And my boundary line is solid, and it looks something like that. Okay? Now I want to figure out where to shade, so I'm going to pick a test point. Well, for this particular inequality in blue, 0, 0 does not live on the boundary line, so I can use that as my test point this time. So everywhere I see an x, I want to put in a 0. Everywhere I see a y, I want to put in a 0. So 0 less than or equal to 8 minus 0, which tells me 0 is less than or equal to 8. Which is true, so I'm going to shade below. Okay, great. Now, we've shaded all of our constraints. What we're interested in is where is the feasible region. The feasible region is where all the constraints overlap. We had 3 constraints in this problem, So we're looking for where all three colors overlap. And I'm going to do that in yellow. Now, again, if you're doing this in pencil, it's probably going to be really hard to tell. I use colors, and it's still a little hard to tell. So these linear programming problems can get a little messy. It's just one of those things we've got to get through. All right, so here's a point. Those three colors line up there. Those three colors line up there. And those three colors line up there. So my feasible region is this triangle piece right here in yellow. And since all of the sides are closed in of my feasible region, this is called a bounded region. Now, I very deliberately labeled my points where the intersection of the boundary lines were. 0, 0, 0, 8, and 8, 0. Because what now we're going to do is we're going to take these points and plug them into our function. That's called our objective function. That's what we want to maximize in this particular problem. Find our minimum and maximum values. So I'm like to list out my points. Just do that over here on the side. I have 0, 0, 0, 8, and 8, 0. Those are the points of intersection for my boundary lines of my feasible region. And again, what I'm going to do is one at a time, I'm going to take my point, x comma y, x always comes first, and plug it into my objective function. So for 0, 0, I have c equals 3 times 0 plus 4 times the 0. But that's pretty easy. 3 times 0 is 0. 4 times 0 is 0, so I have the cost is 0. So what I like to do at this point, my C, my cost, is 0. Okay, I'm done with that scratch work. Move on. Erase the scratch work. For the second point, x is 0, y is 8. I'm plugging into my objective function. So I have the cost is equal to 3 times 0 plus 4 times 8. 3 times 0 is 0. 4 times 8 is 32. So my cost is 32 at this point. Okay, that was scratch work. And then finally for my last point, x is 8, y is 0. I'm plugging into my objective function to find the cost. So I have 3 times 8 plus 4 times 0, which is 24 plus 0. So my cost is 24 at this point. Okay, so now that I've done this, I can very easily see, I'm going to do this in purple, my minimum is 0, my maximum is 32. So my minimum cost is $0, and my maximum cost is $32. And that's how you do a linear programming problem. I realize that these type of problems, one, they're really messy. Two, they take a lot of time. So on your test, you're not going to have a lot of these. Okay, so, but just be aware, they will show up. All right, that's it for this chapter. Now we'll move on to chapter 2.